welcome to the House of zk Radio, which is a focused podcast and media channel exploring everything zk, zero knowledge. I'm Alice, House of zk Radio host and also education lead at zkM. I'm joined here today with co-host Pavel, who is DevRel lead at zkM, and our guest Sinka, who is founder of Delphinus Lab. Thank you so much for being here today, Sinka. We're really excited to have you. Yeah, I'm wondering, Sinka, if we can first start off with an introduction of yourself, how you got involved into the Web3 and zk spaces.
Okay, this is Sinka. I'm the founder of Delphinus Lab. I used to be a OS engineer and in working for a fairly long time in the operating system and the form methods for a while. And after that, I created a dev shop. It's the Delphinus Lab. It actually does everything in Web3, like auto staking, trading robots, blockchain, infra, and we started to do some of the CK stuff, I think back to 2021. And back to that time, we're using zkVM. Right, so, and we have the idea about building a CK, at that time not zkVM, CK JavaScript, because we like the dynamic and the Web2 style, but that project fails fairly quickly because JavaScript has a disaster feature of closure. Based on that experience, we noticed that some guys doing fairly well in zkEVM and zkRISC-V, and after that we start to analyzing whether we can do a new zkVM called zk WebAssembly. Still something related to JavaScript, but it runs in the browser, but this time a little bit nicer because it does not have closure. Thanks.
Got it. And yeah, I'm wondering if we can talk a little bit about your views of the current state of zk right now. I'm curious to hear what you think are some of the biggest issues, biggest challenges facing this space today, and maybe some reasons on why zk hasn't gone completely mainstream yet for developers and for users.
Yeah, I think if you're talking about the main issues that zk has recently, is that, I mean, in academia and in the zk group, that everyone's very exciting because we know maybe too much about the details of the CK, and we know that the technology of the CK is progressing and grow very fast, right? And its performance somehow doubles every half year. But the problem is that because we are dev house, we're trying to promote our products to our clients, and unfortunately, most of the clients don't care at the moment, right? They seems like to ask a question about why, but I would like to ask them why not, right? So the reason that they ask why is because they still think that the overhead of onboarding CK is huge. This is actually a myth, right? Because if we're talking with others that is working and experts in the CK narrative, that they might imagine that onboarding CK with so many zkVMs, right, and specific CK circuit writers, it's not that hard. But because the narrative actually branding us as some kind of high tech, right, which will actually selling the illusion that because we geeks, we high tech, it's not going to be easy for you to use it, right? So if I'm trying to sell that, okay, you can do the push button, then this kind of accelerating, right? They will feel that. We would like to actually have a product that runs like Docker. Docker is not that easy to use, right? But people has the feeling that Docker is a push button, right? But zkVMs and maybe zkVMs with a proving network is, I think, at the same difficulty of running Docker Compose. There's still a very hard learning curve, but we do not position us as a tool like Docker, right? It's just a container. Just run your plug in your program in, right? And we will take care of everything. But that does not happen. It might have some other problems like performance, but I think there's so many great scientists here. We can definitely bring the performance to its satisfactory in the near future, right? Coming soon or whatever. But the current selling will be our most difficulty when to promote our products. I'm not saying that everyone has the problem of promoting their zk products, but from my perspective, not every small client care about what we bring to them.
I see. So kind of like the current public perception of zk is that it's just too complicated to put in. I need to hire researchers and PhDs in order to even understand what we're
They're
putting
not
in.
going to say that, right? So, but they will hesitate of when they are going to onboarding zk in certain part of their product, right? They're not going to say that it's too hard or it's too complicated. It's not push button, because that will introduce arguments, right? They don't want to argue with tech guys. They pick by their feeling, right?
Got it. And then I guess, like, in terms of that direction, how do you think would it be easier to communicate the value of zk to people that think in the way of, like, oh, it's not a push button, or at least the perception? I guess what would you think would be the ideal communication if you were to explain to someone right now relating to why you should use zk?
I would try to sell the idea that if you have an RPC server, right, I can immediately upgrade your RPC server to a trustless Web3 RPC server. Actually, there are lots of vague definition about what does that mean. It's a selling sentence, right? But currently, because I'm not actually using our zk on large infra projects, we only mainly targets I think customers running a small RPC server, like a small gaming server that is not connected to Web3 yet. So we would like to tell them, okay, you don't even need to write Solidity contract to actually upgrade your server into a trustless one. But that's a selling sentence, right? It's not true. It's not push button. Still has to do some work. And our strategy is that if they somehow interested, we will do the work for them, which is actually treat their RPC server usually written in TypeScript Expressor, right, and migrate that into Rust. So yeah, and charge a little bit of consulting fee. The reason we charge a little bit of consulting fees, we would like to lock them, because people usually take more serious on what they paid, right? A few K, a few thousand, and then upgrade their version, let them try their RPC server, and tell them that now your RPC server is actually now runs in a zkVM, can be checked on chain. But based on that point, there's no settlement involved. So, but it's still a little bit complicated, right? I still have to accelerate a little bit, because the whole process is still not push button.
I see. So in that case, the people that are buying these upgrades, initially they come in with the reliability of just having your server being managed in this way through this environment. So I guess zk isn't the main potentially selling point, but it's something that will drive future like in terms of upgrades, in terms of the sustainability and maintainability of these products, is kind of under the hood. So I guess Yeah.
It's not,
Treating ZK as like the main focus on why you should be upgrading. Maybe it's the underlying aspects.
yeah. It's basically, well, I have to compare the CK solution with modify their whole service into a Solidity based one, right? You have an event handler written as an RPC server in Web 2, right? If you want to upgrade to Web 3, the obvious way is definitely writing everything into Solidity and put matching and match every event handler to a contract call, right? So it's Solidity API matches event handler, right? So we have to estimate how long will that take and how much effort you have to upgrade in a monthly basis, because the RPC server is evolving every month. So we're actually trying to compete with this kind of upgrade, right? So if they are very good Solidity contract engineers, then they probably just picking the solution of upgrade to pure Solidity version, right? But I found there are chances that there are some RPC server engineers, they don't like the Solidity programming style, so there will be a chance so that I selling them the illusion that you don't have to change, right? People don't want to change, so and the only way that to keep them the old working style is to just run their current program in a zkVM. And the current program actually does not mean the current program they have is actually a new compiled version of their program, right? So definitely they can compile that program into RISC-V if they like, right? If they do not want to actually run them in the browser, then they still can compile them into other zkVM, but maybe at that point when the sales happens, it doesn't matter, right? Why not just compile to WebAssembly? So it's kind of a bootstrapping process for our to get some positive feedback. I mean, I'm at very early stage, so I have to play the trick like this.
Got it. And for anyone in the audience who are wondering about the specific advantages about WASM, or like for WebAssembly. So I'm wondering, like, what was the intention behind adopting ZK WASM based VM? You mentioned, like, when you were first introducing yourself, your team first tried like ZK JavaScript, and that had its own issues, and then you transitioned into WebAssembly. I'm also curious to hear about some of the opportunities that this provides to, say, those more like traditional programmers who maybe just want to prove their WASM applications, but don't really have too much expertise within Web3, within ZK. So curious to hear about what led you guys to transition into the WASM-based focus.
So we initially pick a JavaScript because the JavaScript is native support in the browser, right? So our basic observation is that every product that launches, not every, it's exaggerating, but most of the product that would like to do a POC launch or pre-launch, they will have a browser application client. You think about ChatGPT, you think about Visual Studio, VS Code, they have a browser application client, right? So that means if you would like to do a project that actually has the potential to reach the most audience in the web, then you would like the users to use them in a browser sandbox if possible, right? So it's like, so for example, if I'm running a private, say, I'm running a private small company, right? And I'm going to do audit every month or every year. I'm trying to convince you that my revenue is like, my shop revenue is like 1 million every year, right? And I want to sell that on the internet. It's very hard to actually convince people by just posting a number, right? But if I can just run a program calculating the revenue based on my local data set and post a number, then it will be a little bit more trustless, right? And if the proof can be proved in CK, so I think if the product developed to a certain stage that everyone can access the VM using a very traditional but broadly spreaded application, I mean browser, then it will be fairly cool, right? It's just a very vague vision. So we pick CK JavaScript, and we actually do quite a lot of compiling trick when compile CK JavaScript to a dynamic circuit, but that does not working very well. Until 2022, we changed from JavaScript to WebAssembly. It's because WebAssembly is still the only bytecode that can be run in browser, and based on our observation that if you're running a very small RPC server, they are much more likely to be written in TypeScript Expresso that can natively call WebAssembly. But WebAssembly is not a very nice bytecode, to be honest. And that actually has introduced a lot of problem in Substrate, if I understand it correct. But it supports 64-bitwise arithmetic and 64-bitwise float point, so it still has advantage in gaming scenarios and DeFi scenarios. You will do lots of U128 multiplication and arithmetic, right? So the trace will be slightly smaller, and trace is everything for a CK application, right? In the zkVM narrative, you have shorter trace, then you have shorter proving time. So, but when we started, we don't think about the trace problem, right? I only think about it's very fun and cool to have something that's runnable in the browser and provable just based on the browser witness. Thanks. That's my concern. Yeah.
Okay. So mostly the main motivation came from the native support within the browser. And then you also mentioned that there were some kinds of optimizations that you were thinking of, like for example, having those shorter traces for shorter proving times. I'm wondering if your team has thought of any other or using any other sort of optimizations in order to lower, say, these proving times, these proof generation costs, any other kinds of techniques for this more succinct proving?
I think because regarding the current proving time, there are faster VMs like RISC-0. I think they somehow reach 4 seconds or 4.5 seconds per million instructions. We kind of 7.5 seconds for 1 million instructions. So it's about 70% slow, right? Every 1 million instructions, we use about 7.5 to 8 seconds, right, including batching. So it's about twice the number comparing to some state-of-the-art zkVM in RISC-V. But there are some chances that in certain applications it still could be better. WebAssembly has about 148 instructions, including float point. Right. If you want to simulate float point in 32-bit arithmetic, it will be a little bit more tedious, lots of trace, right? But you can somehow simulate float points or just using our WebAssembly F64, which only costs about 4 lines, right, of trace. So that will be an advantage, but that depends on your program to have lots of float point or a large number instruction like DeFi and gaming, right? But unfortunately, not every small gaming studio that works in Web3 care about this fully provable on-chain game. I'm trying to sell them, but I think there might be a little bit advantage in trace and performance when we are targeting these small game applications. Yeah.
I guess.
And for example, sorry.
Yeah. In terms of the adoption from these like smaller game companies, what do you see being their main resistance? Like I'm aware of just like WebAssembly being potentially maybe this is incorrect, but a bit slower to process than other forms. But it could be I could be mistaken on that.
WebAssembly is slower. If you run WasamTime or WasmI, you can see that sometimes WebAssembly is even slower than JavaScript regarding the running time. But it is still, at the moment, the fastest running bytecode, only slower to JavaScript, and some of the, I think it's still slower than eBPF. Yeah, but beside them, it has a decent performance. It's a browser native bytecode. There are lots of high-end engineers working on the performance on that. So if you look at the conference papers, PLDI last year, there were 4 papers involved in WebAssembly. So that means people still care about them, but it's slow, yeah. But if you compare that to Solidity interpreter or runtime, then it's another story, right? It's slow in the traditional Web2 narrative. It's not slow in Web3, I think.
Mm-hmm. And also, you mentioned previously that, like very briefly, that you guys also use proof batching. I'm wondering if you can maybe explain to the audience some of the advantages that proof batching provides, and if there are any sorts of trade-offs or limitations for using proof batching for, say, certain scenarios. If it, for example, increases computational costs, or if batching and we're aggregating these proofs from different protocols, different security models, different assumptions could have some limitations there. So wondering if you could shed some light into some of the advantages, but then also some of the trade-offs with proof batching.
Yeah, that I would like to see a little bit more about proof batching, but as I said, because our people always talking too much about these kind of things, because we are doing a podcast, and this podcast will be heard from many of the customers, and the proof batching, I think usually we should actually treat proof batching as a very minor effort in the zkVM, so other people don't have to know about proof batching too much information. They will think, oh, no, that's not push button because we have to deal with proof batching, right? It gives them another reason to actually not using zk, right? Because if you're doing a tag like Docker, right, they are not going to say quite a lot about a C group in the Linux, right? As a tag. But because proof batching is a very large tech stack in the zk, so we intend to talking quite a lot on that. Yes, we do proof batching in a very old school way. We do a full recursion, which is writing the verification in a circuit. There's some reason that we would like to do that is because we not treat program as a monolithic program, like it has an entry and has an exit. We're targeting RPC servers, so it's a while loop, right, with preemptions. So that's a little bit different with other zkVMs. So our input and output are IOs that actually write and read through an IO context. So our program is like a constantly running program with something called a preemption point. And the preemption point is a WebAssembly host API. It's just like in operating systems that you have the context switch. So context switch contains two stage. One is the context saving, and then context restore, right? And we call them, just like using the operating system semantics, called preemption. So every single instructions can be followed by a preemption, and at each preemption, between the preemptions, we treat that code trace between the preemptions as a block, and we generate a proof, and we always verify the previous proof before we're doing the proof of the next block. So it has to be a full batching, and the cost will be 2 to 3 seconds if you start from scratch, but if you somehow already have the last proof, right? So it's about 7.5 seconds for each block, and then introduce another 2 seconds to prove the previous proof of the block, and then generating the next proof. So it's a full recursion regarding what kind of batching technique we use. Yeah. So that adds to number about 9.5 seconds if you want doing a full recursion of all the blocks with 1 million trace. So something like that. But it's completely irrelevant to the published APIs, because people are just writing a constant loop in their program, and if they like, they can specify what are the preemptions. If they don't want to specify what are the preemptions, then it can be any instruction after a random instruction, so something like that.
I see. And then I also know that you guys support kind of different modes for the proof batching as well, like the roll continuation mode, flat mode. In what scenarios would developers choose one over the other?
We currently trying to avoid generic proof batching at the moment, because generic proof batching is about saving the time, right? Instead of doing a full recursion, we can maybe prove quite a few blocks in the same time by have lots of proofs batching in one verified proof. We used to do that because last year we still have customers that are very keen on improving the batching proof time. But these days we're trying to hide the options of proof batching just internally. If they do not want to connect a KZG, or I say connect a guest prover with their host circuit, then we're not going to allow them to tweak the batcher. This will cause us to lose a little bit of customers, but I think long-termly we are not going to provide customizable batching anymore. I know that there are quite a few projects would like are selling the product or selling the diversity of batching modes to their customers, but I believe we are not going to do that anymore. But we're going to focus on the full recursion batching of blocks between 2 preemption points.
And this is because of simplicity and efficiency for this, just to focus on one individual system.
Yeah, it definitely causes more batching time. I just want to actually hiding everything behind the VM. Yeah.
Awesome.
So people don't want to know that.
Got it. Yeah, that makes sense. And I also wanted to discuss with you a bit more about optimizing for the developer experience.
Yeah.
And I know that for Delphinus Lab, you offer multiple different types of tooling, multiple different types of just support for developers, like the zkWASM SDK,
Yeah.
the Hub Cloud service, and
Yeah.
through that you offer automated proving, different WASM extensions.
Yeah.
So wanted to hear about some of the motivations behind providing these tools and how it affects the end developer.
Yeah, I mean, back to 2022, when we're trying to do very small scale selling on the VM, customer get excited. They download the VM, they write a program. They want to write a program about a hello world, which includes a printf, and they get constant failure, right? So it's like I spent about 3 hours, 4 hours teaching them how to use the zkVM, how good the zkVM is, and the failure for them comes just after maybe 2 minutes. They try to use the VM because the CK does not support printf. You will try any other zkVMs, right? The printf has to be redirected into a CK specific IO, and you have to use a tweaked crate for Rust, right? For C, you have to tweak the IO. And if they call, so because when people write their generic applications, they interact with Linux, right? They take it for granted that they can use API calls like memset, memcopy, memallocation, printf, file open, file read, not to mention the internet connection, right? And that's another reason we pick WebAssembly. I forgot to mention, because WebAssembly actually has a formally specified firmware architecture called WASI. It defines what kind of operating system that WebAssembly is trying to. It's a virtual operating system that WebAssembly is trying to interact. So the reason that we provide several services is basically we would like to abstract what kind of customer needs and what are the architecture the customer assumes that they are interacting with. There are customers, they insist that they need to have printf for debug. Right. So that cannot be supported in the WebAssembly level, right? Because WebAssembly does not have printf, right? No bytecode actually has printf. Printf is the I/O thing. You can do memory mapped I/O, or you can do system level printf. So if people insist on that, then we provide some kind of WebAssembly SDK. So we have a WASI environment for them, right? So, and anything that regarded to printf, it prints to a specific column of the circuit, and we will actually hash the circuit so that they know what they have printed has committed to something. So that's one thing. There are also customers that insist that they need to check the trace in the program, right? So provide host calls so that they can calculating the trace. And the reason they ask them why you actually have to trace the number of traces, right? There's no reason. There are people that they just insist. I have to know how many traces I have caused in my program, because that affects the proving speed, right? They cannot tolerate that we run the program and do the trace calculation at the end. They want to know dynamically. And there are other customers that they would like to try their own specific host circuits, which is sometimes it's not KZG circuits, not Halo 2 circuits, and not even FRI circuits. They want like to do they have a multi-variable GKR circuits, which is very crazy, right? So then we have to provide a host APIs. The thing that we provided that we would like to adding some plugin in our batcher, so help them to prove that we have two vectors. One is a univariate vector, the other is the multivariate vector, and it has a univariate vector commitment. It has a multivariate derived from zero-morph commitment, and these two commitments actually related to the same vector, right? I have to write things like them so they're happy they can do the connection, but from my observation is that most of these very tech customers, they don't have application. They're just doing experiment on that. So we have an experiment SDK for them, just trying to keep up with them, right? But they're not really real applications. And there are customers, they do not want to do the proof. No single proof is generated from some of the customers. I'm not actually selling a proving market, right? All the provers I'm hosting I think it's not a decentralized proving market. It's just the cloud. So people just submit their witnesses and generates proof. Yeah. So these three level of services: the proving cloud, the SDK, and the host circuit SDK, for different purpose, right? But because we are doing a lab, we would like to actually ease curve for the user, so I have to support random services, something like that.
Yeah, it's very interesting and like very impressive about kind of the approach for balancing all of these customer wants. Like you mentioned that some want to adopt primitives and check all these individual traces in their program, or some want to have their own host circuits. And you also mentioned like some are more in that experimenting phase as opposed to like building applications. So it's very interesting to see how you guys approach with balancing all of those individual needs. And I also wanted to ask about some specific applications that come with like zk WebAssembly. So you mentioned before that like for WebAssembly, there's some DeFi and some gaming scenarios where it could be advantageous. I'm also wondering if there's any like particular applications that you find most promising to application builders, to zkVM builders, even to like rollup builders. So just curious to hear about some of the applications that you find most promising.
So from my side, because I'm not doing zkVM for large info projects, we only do on small projects. Our observation is that if we will not achieve that point at the moment, to be honest, but if you can turn any RPC server into a trustless server, then there will be a huge market space there, right? You can somehow derive the not very prosperous but still existing narratives called serverless RPC servers. Many shitty RPC servers running in WebAssembly. If you can somehow get customer from that space, there are lots of Express. There's a library called Express. It's a very shitty, slow TypeScript RPC server, but so many junior guys actually using that, writing their RPC server. But you can derive from them, then you can convince them to make their server as a trusted Web3 server, right? And there are lots of in Web2 seems crappy, but I mean, standalone applications written in a language it's not. It's kind of shrink the C++ library. They looks crappy, but people start porting them into the browser. but they might be just too crappy. I mean, not our ideal customer, but still RPC server will be the main target that we are focused on. So there are also substrate users. I'm very interested in substrate users. Our WebAssembly interpreter or witness generator is a modification version of substrate's WASM-I, right? So that means there are potential that I can turn all substrates applications into a Ethereum layer 2, right? But the problem is that quite a few substrate users still fans of Polkadot. It's very, very hard to turn them. Need your help spreading, right? Turn them back to a roll-up service instead of using Polkadot as the main underneath info.
I like that point where you can take existing implementations and just abstract functionality, add the EVM essentially within this this system. Really cool to see. Have you experimented with any like bridging use cases where like cross-chain interoperability between these different ecosystems? If you have.
Sorry, no. I'm running a dev house, so I so far I see DeFi pays us, gaming pays us, and this kind of provable AI. People trying to run Llama to not 7B Llama to 32 megabytes model in a provable context, so connecting GKR circuit with WebAssembly, but I never see a customer in the cross-chain service that actually willing to pay. I mean, no matter how fit the technique is for them, if there's no paying market, right? It's a bit hard. They do ask why. You still have to using multi-signal indexer to get message from other chain. Using layer 0 is good enough, right? I actually like the idea of axioms proving the history of Ethereum, right? But when you're doing interoperability between different chains, not every Solidity chain runs standard POS, right? It's hard. Selling is very hard for dev shop. It's like you have to convince them it's good, it's cheap, and people are maintaining that. So and it can be better. That's also very important. Give them hope. I mean,
definitely. Like I could say that within the cross chain space, a lot of it is like I guess a lot of applications are built in a way where it's like we'll add in our own blockchain, our own form of consensus, and then validate transactions going through it. And a majority of different bridges that operate in their own blockchain to connect other blockchains. But then, it makes sense that you know the interoperability of the cross chain space, you know, it focuses on areas of creating like these funnels where people can add like these like fee generation spots. So I guess like interesting that you mentioned how you know it needs to make sense from the business perspective on the overall like implementation, and then how am I gonna make money at the end of the day, being like a cross chain interoperability provider. So good that you mentioned like
you're saying that you proving the OP stack that makes good money, right? Mm-hmm. I'm not doing that, but if people are definitely pushing the boundary of proving OP stacks, in maybe CK fraud proof or proving the whole trace. I mean, fast run the whole trace. That makes sense. That's a lot of good money in and demand in that narrative. But cross-chain. It's a very fragile narrative. It's hard for CA to charge, right? To charge the service. Yeah.
Makes sense.
And then also, you mentioned this very briefly about the proving network that's offered within the zkWASM's hub. And I'm very interested in hearing some of the different design considerations that were prioritized within the prover network. I know that you guys really emphasize the B2C model as opposed to the B2B model, and then you have specific incentive structures for participants of that network. So I wanted to hear some more about some of the motivations behind certain approaches that you took when designing the prover network.
Okay, so maybe I ask maybe that might contains four questions, right? Well, first is how the proving network works, right? It's not a proving network; it's a prover organizer. It's much smaller than a proving network. It's a cloud. You publish your task. I do the matching for you. Find a GPU that can do the proving for you, right? And that's the first question. The second question is that the incentive is that if you join the proving network, you provide the 4090 GPU, and every proof you generate, I give you credits. And that's, I think, a potential selling point of if we launch a token, then the credits can be converted to a token. But that is a little bit tricky, right? Because so I can sell to our customers that the proving is free, but it's not free at the moment. It's free, but it costs my credit, right? But I don't think others actually charging the proving fee successfully in the market. So I cannot charge a proving fee. But if I do not charge a proving fee, then every proof still costs about 1 cent, right? It costs about 10 seconds. If they have a large trace, and 1 minute of GPU calculations, about several cents of USD dollars. We get about a few K proofs every day, then still some money, right? You need to actually run the cluster. And the third question is that the design based on the proving service is that at the beginning we are very ambitious. We want to do a decentralized incentive proving market, support all zkVM. No, okay, none of them actually succeed. I mean, so now I'm doing a centralized regarding to the decentralized vision incentive, but using credit, right? And not including all the VM, but only our VM. But it works fairly well because the user don't care whether it's decentralized, because they want to download the proof. They want to submit the proof to the Ethereum and do the settlement, right? They don't need decentralized. They don't care what kind of incentive they give into the provers, right? As long as you're not charging them, right? And I'm not going to use your prover for other VMs because I cannot do better than other VMs proving network, right? So now that ends up, we have a name maybe before for that. It would be a zkWASM proving network, but now it's become a zkWASM hub, just like Docker Hub. It's a push button proving cloud. Yeah. But it's very important. It serves our vision of actually selling zkWASM to others. Because the zkWASM uses KZG, which derived from the old Halo 2 scheme. It runs slowly in CPU, right? You have to have a GPU to run that. But this kind of cloud actually shrink the gap from dry run to proof generation. People see the result in 10 seconds. They're happy about the constant seeding of the proving result. So it's nice. I'm happy with the current design.
I like that. And also just a point in regards to the need for a GPU. Is it
Yeah.
possible within WebAssembly to access the GPU of the computer? I know like maybe escaping a browser
Yeah.
is very very difficult because it's in a sandbox environment. But are you able to leverage the characteristics of the machine to generate proofs more efficiently?
Yeah, we're using GPU to generate the proofs. It's 4090 in our zkWasm hub. We require everyone would like to join the proving hub to have a 4090 or at least L4. Um, and we have I think in the GitHub we have a prover that's purely written in CUDA. It's not a must, but if you run in CPU, then it costs you about 200 seconds because KZG runs super slow in CPU. And no one's actually optimizing the CPU version of KZG backend. So I think GPU will be the only solution. We will provide GPU solution not because it's an alternative to CPU. I think it becomes a must because comparing to FRI-based prover, they can run fairly decent in CPU, right? 40 seconds, 30 seconds, 50 seconds. And if for RISC-V, RISC-0, maybe they can run 20 seconds, 10 seconds, right? But KDG backend zkVM it's too slow in CPU. We have to have a GPU for that. But well, actually regarding GPU, then everything's fine, right? 148 instructions for WebAssembly only costs about 7.5 seconds for 1 million instructions, 64-bit, right? So it's fairly decent.
And I guess like, do you see a future where I know you're using dedicated remote provers, so you're sending them the information for them to prove. Do you see there being a local prover or a client-side prover being able to run this, and you being able to maybe access the local processing power of the machine, if it like maybe meets the minimum criteria to do local proving without them taking a couple hours?
You can download our prover. It's a cloud prover. You download prover, you host locally. I mean, it's a short answer. The long answer is that if you want to run a local prover in your own machine, right, and then you have to have a decent GPU card like L4, right? But I think the tech of CK is moving very fast, right? So maybe we have a reference implementation of the CK WebAssembly. I'm not saying that it will be the only implementation, right? There might be other implementation, but as long as we can fit the API with maybe a new CK WebAssembly implementation with a very high-tech, up-to-date schema, then you probably can prove that in your local machine, right? I mean, but currently, you need a GPU to prove that. Yeah. We are also trying new schemas, but most of schema has difficulties dealing with U64. Well, we are trying, including FRI.
Yeah, got it. Lots of new developments coming up. So right now is kind of like the trial period, but later on be moving into some more developments towards there. So that's very, very exciting. But yeah, thank you so much, Sinka, for all of the insights. I really liked hearing the perspective from DevShop and being able to customize exactly for your like clients' needs while optimizing for cost, and then your guys' vision for that push button design. and then also all of the insights with all the opportunities within the WebAssembly ecosystem. So really enjoyed hearing all of that, and really appreciate you for being here today.